Chapter 3, Section 5 is about slopes of lines. So by the end of this lesson, you should be able to find the slope of several lines, and then use slope to identify if lines are parallel or perpendicular to each other. So hopefully this will be some good review from algebra, but the slope of a line is defined as the rise divided by the run. Rise is the difference in y values. It's how much, if you're looking at two different y values, it's how much you need to rise up to meet that other y value. And then your run is how far you go on the x-axis. And this rise divided by run is your slope. So if you have a graph, sometimes it helps to just count rise over run, but this is the formula where you take the difference in your y values, so you're basically finding out how much room is right here, divided by the difference in your x values, so you're finding out the distance right there. y2 minus y1 refer to the second y value minus the first y value, and x2 minus x1, same thing. You're looking at your second x value, take away your first x value. So use the slope formula to determine the slope of each line. Slope formula is m stands for slope, y2 minus y1 divided by x2 minus x1. So we look at our 2 points here. Point A is at 2, 3, and point B is at 7, 5. So all we have to do is plug it in. I know my slope is going to be my second y value. And it doesn't really matter which one you make second, so let's say 5. I'm going to do 5 minus 3. And then divide that by my x values. So 7 minus 2. Now I know I said it didn't matter, but make sure that your points line up. Like 5 and 7 came from the same point. 3 and 2 came from the same point. That has to happen in order for the slope formula to be correct. And then all you have to do is subtract. 5 minus 3 gives you 2, and 7 minus 2 gives you 5. And then because we have the nice neat little graph here, we can check it. If I go up 2 over 5, I get to that B. Now this one's straight up and down. So find the coordinates of our points. This one's over 4, down 3, and this one's over 4, up 5. If we go and plug this in, let's make this our second point and this our first point. We'll do 5 minus a negative 3, and then 4 minus 4. Now on the top, remember, if you subtract a negative, you're really adding here, so we end up with 8. But then we divide by 0. And we cannot divide by 0. This can't happen, so this is undefined. The slope of any vertical line is undefined. It does not have a slope. So let's do a few more. This one's a horizontal one, so it's kind of similar to the vertical one that we just did. But if we take a look at our points here, which is at 3, 4, and then 6, 4, when we plug these in the formula and subtract our y's and then subtract our x's, let's call this point 2 and this point 1, we get 4 minus 4 on the top and then 6 minus 3 on the bottom. Now this time around, we end up with 0 on top. That can happen. 0 divided by 3 just means that you have a piece of pie, it's cut into 3 pieces, and you don't eat any of them. That's totally okay. The answer here is 0. So remember, horizontal lines have a slope of 0, and vertical lines have an undefined slope. Think if you were trying to ski, you can totally ski on a line like this. So it has 0 slope. But one like this, you're not allowed to. This has an undefined slope. And now this last one. We have 2, 6, and then 6, 2. So when we go and plug this in, let's call this point 1 and this point 2. Remember, it really doesn't matter. I'm going to do 2 minus 6 on the top, divided by 6 minus 2 on the bottom. And if I subtract these, I get negative 4 divided by 4, or negative 1. So sometimes it can simplify to something nice and pretty, which means I go down 1 over 1, down 1 over 1, and all of these are points, even though they weren't points that I was told to find. And then other times, like the first one we did, you just get a fraction, which is totally okay. So a summary, positive slope goes up as you read from left to right. Remember, we read a graph just like we read a book. So as we move this way, the line goes up, positive slope. Negative slope is just the opposite. As you go from left to right, it goes down. Zero slope is straight across, and undefined slope is straight up and down. And then sometimes slope is also called rate of change. So in this problem, y is going to represent our miles that we traveled, and x represents the time in hours. So if we find slope, remember slope is rise over run, and we just said that y is miles that we traveled in hours, this is going to give us miles per hour. So let's say Tony is driving from Dallas, Texas to Atlanta, Georgia, and at 3 p.m. he's 180 miles from Dallas, so right here. And then at 5:30 p.m., he's at 330 miles. We need to use this to find the slope and then figure out what that slope means. So break out our slope formula. y2 minus y1 over x2 minus x1. Let's make this our second point and this our first point. So if we take a look at our y values, I have 330 minus 180. Divided by 5.5 minus 3. So 330 minus 180 is going to give us 150. And then 5.5 minus 3 is going to give us 2.5. And if we divide 150 divided by 2.5 in our calculator, we end up with 60. Now what in the world does this mean? It means I go up 60 over 1, up 60 over 1. So in this case, that's 60 miles in 1 hour. So he's traveling about 60 miles per hour. So because this is geometry, not algebra, of course we have to throw some theorems in here. So here's two more, parallel lines and perpendicular lines. Parallel lines are only parallel if they have exactly the same slope. So two non-vertical lines, they have the same slope. Any two vertical lines are parallel, so the lines like this. We can't say that they have the same slope because they have an undefined slope. And then the perpendicular lines theorem says any two non-vertical lines are perpendicular if the product of their slopes is -1. Vertical and horizontal lines are always perpendicular. So because one has an undefined slope, we can't say that they multiply to make -1. But perhaps you remember from algebra class that we would say that the slopes are opposite reciprocals if they're perpendicular. So let's say one slope was 3, the perpendicular one would have to be 1 over 3, and then you make it negative. So when you multiply these together, you end up with -1. So the definition is technically that their product equals -1, but we always call them opposite reciprocals. So graph each pair of lines, and then use the slopes to determine whether the lines are parallel, perpendicular, or neither. So the first one we're going to graph is WX. So we just need these 2 points right here. So I'm going to go over 1, 2, 3, up 1, and over 1, 2, 3, down 2. So this is a nice vertical line. And then the other one they told me to graph was YZ. So that's back 2, up 3, and then over 4, up 3. That's a nice horizontal line. So because the blue one has an undefined slope, we can't multiply their slopes together, but because one is vertical and one is horizontal, by the perpendicular lines theorem, we know they have to be perpendicular. So now let's try another one. KL. So these 2 points here is -1, 2, 3, 4, up 1, 2, 3, 4. And then -2, -3. So this line right here. And then the next one is MN. So over 1, 2, 3, up 1. It's a popular point. And then back 1, 2, 3, 4, 5, down 1. Now just glancing at the purple and the red, hopefully you're thinking that they might be perpendicular, but we need to prove it. We can't just say, oh, it kind of looks like a 90-degree angle, so it must be. We have to find the slope of both. So if we look at the red one, we can use the slope formula. It says take your second y minus your first one, divided by your second x minus your first one. So we get, let's call this 0.1 and this 0.2. So we have negative 3 minus 4 on the top, and then negative 2 minus a negative 4 on the bottom. So we end up with negative 7 on the top. Remember, this is addition, so negative 2 plus 4 just gives me 2. So that is the slope of the red one. Now let's find the slope of the purple one. So same formula. Let's call this 0.1 and this 0.2. I'm going to do negative 1 minus 1, and then negative 5 minus 3. This gives me a negative 2 on the top, divided by a negative 8 on the bottom. Now I need to simplify this, so this turns into 1/4. Now remember we said in order for something to be perpendicular, their slopes have to multiply to make negative 1. So if I do negative 7/2 times 1/4, I end up with negative 7 over 8, which is pretty close to negative 1, but it's not. So this is neither parallel or perpendicular. So it's the end of the lesson. You should be able to find the slopes of lines and then use the slopes to figure out if things are parallel or perpendicular. Make sure you write down any questions you have and we can go over them tomorrow. Have a good night.